efficiently. Welcome, everyone. My name is Erin Whitney, Director of the Arctic Energy Office. In case you're wondering about what I'm doing here in the middle of a federal shutdown, I'll just say that most DOE offices carry reserve spending for situations just like this. So we are continuing to work limiting some of our activities, but since I'm not a featured speaker, I decided to continue on with this meeting, and I'm happy to see you all and hoping for a resolution soon in Washington, D.C. This is our October monthly Hydrogen Working Group meeting, and love this group. Appreciate everyone's participation. We're looking forward to having a speaker from Edmonton, Alberta, Canada today, from Azolla, Jared Sayers, on methanol solutions. But before that, we always allow time for introductions and announcements. I will just start off by saying that I am aware, as I'm sure many of you are, that the Pacific Northwest Hydrogen Hub was canceled. I can't say much more about that. I'm sure there will be some protracted discussions and maneuvers around that. And I am following announcements just as you are. So with that, I would love to invite you all, anyone who is new to the group, to introduce themselves. Or if you have been on the group and haven't introduced yourself previously, I can assure you it's a friendly group, and we would love to hear from you. So are there any introductions or announcements?
I'm new. I'm Ariel Svetlik. I work for Representative Mears, who's the House Energy Chair at the Alaska State Legislature. She can't make it today because she's at the gas line caucus, so I'm here in her stead to take notes and learn from you guys.
Thank you, Ariel. And if you wouldn't mind putting your contact info into the chat so folks can connect with you, we would all appreciate it.
Sure thing.
And let us know where you're calling in from. We get people from all over the place here.
I am in sunny downtown Anchorage right now. Midtown,
Wonderful.
I should say.
Thank you. All right. Other introductions, either from new or quiet people?
Hey, I'm Erin McKittrick. I know you already, not everybody else here. I'm also working for Representative Mears now, and am here for the same reason as Ariel.
Excellent. That's a fun and interesting development, Erin. Great to hear from you. And please put your contact info into the chat so folks can connect with you. We appreciate it.
John Walsh here in Juneau. Thank you for the hospitality here. I am a registered lobbyist. I met and spoke with Mark Myers during the energy conference in June, and sort of excited my interests, and so somehow I found my way to your working group. So thank you, and I'll put my information in the chat.
Thank you, and welcome. Great to see you. Aidan Nickel, I see you off mute. Are you getting ready to introduce yourself, or am I putting you on the spot?
Yes, happy to. My name is Aidan Nickel. I'm staff to Representative Holland, who is co-chair of House Energy Committee. He is also at the Gasline Caucus meeting today. So like Ariel and Erin, I am here in his place.
Excellent. Welcome. Please put your contact info into the chat. Great to see representatives of our representatives. All right. Other introductions or announcements? Go ahead. Go ahead, Johanna.
Yeah, I'm Johanna Kolmans-Beinen. I'm in the Arctic Energy Office with Erin and new on board there. So if there's anything we can do for you all, let us know.
Thank you. And Johanna is calling in from Washington, D.C., hence why she said it was 80 degrees and she's wearing a tank top. So she is a great presence for us in our DC office. And those of you who have traveled to DC, who have reached out to us to help you with appointments or meetings, may have interacted with Johanna. She's been with us since the summer. And this is just a plug again, if you're heading to DC and you're trying to make the most of your time with regard to Department of Energy meetings, let us know. Let us help you find the best match, help make appointments. Sometimes we can get better responses through our connections than cold calls and cold emails. Not always, but we do what we can to help. And also now visitors need to be escorted in the Department of Energy Forestall building. So this is something else that we can do for you to make your life a little bit easier. Thank you, Johanna. Other introductions or announcements for the good of the group? Anyone? Anyone? I do see some new names. Don't be shy.
I'm Robert Wiley. I'm based in Houston, and I dream of the temperature dropping to 80 Fahrenheit. I was up in Alaska last week, had a great time. I thought it was always sunny and beautiful up there. I've got a lot of background in the energy industry in general, particularly from the downhole side. But my main focus is consulting in both wellbore positioning and product commercialization. I'm also connected into global energy and particularly Scottish products and companies.
Excellent. Thank you very much. From one temperature extreme to another. Welcome, and please put your contact info in the chat so folks can connect with you and any other sort of relevant organizational info. Any other introductions or announcements?
Erin, I had an announcement.
Go ahead.
This is Allegra Housefordshire. I'm a consultant in natural hydrogen. I spend most of my time working on geologic hydrogen, stimulated hydrogen, and one of the things I'm working on right now is helping Stanford boot up a industry consortium on natural hydrogen. They don't currently have one, and that was something that I did for them for 16 years for a petroleum system industry consortium. And I'm going to help them boot up a natural hydrogen industry consortium. So that's coming, and I'll be talking about that on LinkedIn. And I was just in Alaska last week, and it was 50 degrees and rainy. So
I'm sorry.
it's okay.
The last couple of days have been absolutely beautiful.
Awesome.
Please put your contact info in the chat. I know there's a couple folks on here whose ears are perking up at that announcement of a consortium on natural hydrogen, and we'll probably love to get in touch with you.
Great. I'll put my Stanford address instead of my consulting address. Yeah.
Thank you. Thank you very much. Other introductions, announcements, thoughts, questions, reflections, musings. This is a space where we can have these informal sharing moments before we jump into our presentation. Okay, going once, going twice, gone. There'll be more time at the end if you think of something that you should have said. So we will go ahead then and roll into our presentation for today. We are privileged to have with us on the line Mr. Jared Sayers from Azolla. From Edmonton, Alberta, Canada, talking about methanol solutions. So, Jared, I'm going to hand the floor to you or Patty, whichever one of you agreed to share your slides. And we will let you take it away and say more about your background and anything else to cue this up.
Perfect. I think hopefully this will work. And I appreciate everybody's time here today. And
we see that. Looks good.
Okay, perfect.
Jared, before you start, this is Allegra. If you could minimize mouse movement with your with the mouse or the cursor movement, that would really be good for me.
Okay.
As you're presenting.
Perfect.
Thank you.
Okay. I'll try not to touch. I'll take my hand off that because usually I do that. So perfect.
Excellent. All right, go ahead.
So thank you very much. Super excited to be here. My name is Jared Sayers. As mentioned, I'm President and CEO of Azolla Hydrogen. Azolla Hydrogen is a fairly new company. We started in 2021 with a goal to try and help with being a part of the decarbonization and clean tech. And my background is oil and gas. I was born into oil and gas, I guess. Everything from I started when I was about 16 doing hot taps into the oil and gas pipelines and plants. And then when I was 19, I was involved with the fires of Kuwait in 1990 and 91, and then started a company called Red Flame Industries in 1996, I guess, until 2013, and where I sold it to a private equity company. And then we had done pipeline hot taps and tie-ins in both pipelines and plant systems. And interestingly enough, I dealt with hydrogen-induced cracking. So in one way or another, I've been dealing with hydrogen for a very long time now. So we're super excited to bring Azolla Hydrogen to the market. And Azolla was really started with the intention to help solve the real world hydrogen deployment challenges. You know, in early 2019, I started looking at different technologies, everything from electrolysis to pyrolysis, and you know, understanding the pipeline and oil and gas and how it functions. We saw a real challenge to the market to be able to supply hydrogen. Even though, you know, in Canada and in Edmonton, actually, I think we produce the most hydrogen in North America out of Canada. So, but the challenge is that we consume it exactly where we need it. So as soon as we start to move that molecule, it becomes challenging. And so we wanted to come up with a solution that we could was pragmatic and kind of an infrastructure first approach to solving the hydrogen challenge. So we saw some market gaps and especially for transportation. So we wanted to ensure that you know, everything 100% hydrogen fuel availability. And so when we first started, I moved to Los Angeles and kicked the tires on every station in Los Angeles. And I lived there for about 9 months, understanding whether it was a supply problem, an equipment problem. And because there was so much hype around hydrogen, we wanted to understand what the real deal was. So it turns out there's a bit of a challenge on both sides, both on the molecule itself and supply and the way it's supplied and the areas that it can serve, and then also with some of the equipment and how it is being utilized. So when we looked at this, we wanted an approach that would balance you know, everything from, you know, the speed, the scale, the carbon intensity, and what would make hydrogen deployable today and be able to serve some of the challenges and serve some of the market with hydrogen. So we came up with some methanol as a hydrogen carrier, and we use methanol and deionized water to actually be able to produce and compress, store, and dispense all on site. So we co-locate, and we've been successful in getting some adoption, and we've been able to move forward with some of our projects. And this is probably one of my most favorite slides, in the fact that we're actually not just talking hydrogen, we're actually producing it and we're making it. So our Ellerslie station here in Edmonton, Alberta, and actually I should, in full honesty, I'm actually from Calgary. So our station's in Edmonton, but I'm in Calgary as our head office. And although I am an Edmonton Oilers fan, so but the Ellerslie station has been up and running for the last couple months, and it's 225 kilograms of production with 600 kilograms of storage available. And I'm pleased to report that we've hit 100% fuel availability for our buses. So we're refilling buses every day, and that station is working well. And we'll be building a second station in Edmonton at the Edmonton Waste Management site, which will actually produce, we're going to scale that up to 450 kilograms per day, again with 600 kilograms. And then our third project is the Winnipeg Transit Facility that'll come on actually later this year. And that's a permanent station with 450 kilograms of hydrogen production. and 600 kilograms with a potential to go up to 1,200 kilograms of storage. So the nice thing about Azolla and our projects, we demonstrate the ability to deliver, the reliable hydrogen infrastructure. So, when I talk about fuel availability and whether it's a municipality relying on it or a trucking operation, people want to ensure that when they pull up to the pump that there's fuel available and they can keep their vehicles on the road. So we kind of keyed in on that, and we've been successful in achieving that milestone. So some of the challenges with existing systems is, the logistics of transporting hydrogen and the complexity of trailering it into site, and what you could do with that hydrogen and how challenging it is to move and store. We seem to have solved that challenge by being able to build on site and being able to match both the supply with the demand and be able to handle some of the variances and the integration challenges that come with that. So yeah, hopefully this is a video of our Ellerslie station in Edmonton, and you can see we co-locate with the Fleet Facility Services there. And the station itself has a fairly good minor footprint. And like I said, we're able to produce, compress, store, and dispense hydrogen on site and be able to refuel buses at 350 bar fueling. And we're seeing very good success out of this project. And because we've been able to integrate all the components, so we own all the software and the integration from production and compression and storage, we've been able to control all those electronics and all of the components that go with that, which is an integral part of, I think, some of the success and the challenges that we've overcome is making all those components talk to each other and being able to be efficient in our operation. So when the challenge with sometimes being able to produce hydrogen on site is making all the components talk to each other and balance so that the reformer, when it builds hydrogen and we produce hydrogen, then it goes into the compressor and the compressor suction and the discharge pressures align and are optimized into the storage. And then how we store into the different banks allows us to be able to improve the refill time on the bus. So we're refueling buses today in about 12 to 15 minutes. So it's very similar to a diesel refueling time, which we think is important. And again, one of the metrics that we keyed in on and be able to utilize the different storage and be able to do the gas management system and control that ourselves. We ensure that the proper fueling happens time in, time out. And, the nice part about how we've been able to de-risk some of the projects is by being able to right size that production and be able to produce close to what our demand is, has been a key element in our success in the fact that we can manage that production and be able to store it in a reasonable amount and footprint to be able to accommodate the demand for the vehicles and ensure that we can complete the fills and we have available fuel for the buses at all times. So when it comes to hydrogen production, we've been able to scale up from a 225 kilograms to also 450 kilograms per day. And that's kind of being able to match, again, what we saw was a reasonable and practical amount to be able to match up with the demand. And most hydrogen fueling stations throughout even California today only have about 200 kilograms of demand per day. So we thought it was a reasonable amount, and I think we just right-sized it to be able to, again, not overbuild and be able to keep the CapEx and the OpEx down so that we could provide reliable fuel at an affordable cost today for hydrogen. So we're super excited about the performance of the unit and some of the things we're seeing from an electrical usage and power efficiencies. I tell everybody that, we're not perfect today, but we're getting better every day, and we're improving the systems, and we're improving the technology, and we're learning more and being able to accommodate our customers' needs when it comes to refueling times and doing back-to-back hydrogen fueling, and improving how the system manages both the storage side and the dispensing side too. There's a lot of challenges with hydrogen molecules, and we've been able to test different equipment and improve the reliability of the equipment. And one of the nice things that by being on site, we've been able to look at the equipment and continually optimize what we have for equipment. And because we're not a large facility or anything like that, we can change out parts if we have to, or do maintenance. And that's the nice part about having 600 kilograms of storage capacity, is that we can do regular maintenance or upgrades with taking the system down, but still having fuel availability to the dispensers, so that when the bus pulls up, they always have fuel available to them. So, and then again, as I'll point out, like our nominal site requirements are about 540, I'll use square feet for the 450 size. And the nice part about Azolla is that we've been involved in doing all the permitting, setbacks, and all of the requirements for the station itself. So we've kind of taken I guess, more responsibility when it comes to that, ensuring that we meet all of the local jurisdictions having authority and the permitting requirements. Because we understand the equipment and we operate it, it's easier for us to be involved with the permitting, and we've taken a lot of the risk away from having permitting delays and things like that, by being able to be involved with the permitting and the selection and operation of the equipment itself. So in Winnipeg, for instance, we're in Edmonton, both we're hiring local people to come and join the Azolla team, and we own, operate, and sell kilograms of hydrogen to our clients. And it's been be able to good integration of the technology, so that by having an operator on site who understands all of the equipment, it allows the bus drivers or the vehicle drivers or others to just be able to come up and still do their job, and we handle all of the hydrogen production and supply. So it helps with the pilot integration, and for others to get comfortable with working around hydrogen and understanding some of the complexities with working around it, and some of the site requirements as well. So I think that's a fairly quick overview, and hopefully I didn't go too fast, but yeah, glad to answer any questions or go back.
Thank you, Jared. It's exciting. This is where we open it up to questions. I have a few, but would love to open it up to other folks on the call. Jamie, go ahead.
Yeah, thanks. Sorry, I think I missed it. This is an electrolyzer tech, right?
No, it's
Or is
not.
it
It's actually,
Okay.
so we use methanol as a
Okay, it's a
hydrogen
methanol
carrier.
reformer. Great. Okay,
Methanol and deionized water. Yep.
perfect. Yeah, that's fabulous. That's where I started in my hydrogen journey, was methanol reforming, so it's near and dear to my heart. Second
Yeah.
thing, how many back-to-back fills can you do in a row?
Yeah, great question. So it depends on the size of the tanks and obviously the amount of availability in the tanks themselves. But on any given system, I guess the real answer, it depends on exactly what we're feeling and what pressures. But for the 600, like we have 600 kilograms at 550 bar. So that actually comes down to about 500 bar, sorry. But so we can do, to pick up, depending on, again, if you're talking buses, it's probably 6 back-to-backs.
Okay, so you can actually do it, but I mean, sometimes people have challenges keeping the hydrogen cold and the system. It's not so much that you have the hydrogen tanks there, it's everything else. Yeah, thank you.
Yeah, the challenge with you're right, the reverse Joule-Thomson effect of the flow of the hydrogen. So we do cool the hydrogen as we're dispensing it through a heat exchanger. So yeah, we do typically keep that anywhere from, depending again on the project, from 0 degrees Celsius to about -20 degrees Celsius. And I apologize, I won't try and convert that for you, but you can do
Well,
the
I thought
conversions.
I thought the protocols were -40 degrees Celsius for refueling of at least light duty vehicles. It's -40.
So light duty, again, yeah, you're right. So there's different fueling protocols for different vehicles, and tank size is really what comes into consideration there. So we do have infrared sensors on the nozzles themselves at the dispensers. So we do take into consideration the temperature and the pressure in the tank and what size that tank is. So yeah, right. You're right. Most light duty, like if you're doing Toyota Mirais, but that's only 5 kilograms. Like buses are taking 30 kilograms or more, depending on the tank sizes. So we're doing 350 bar fueling, and we can fill faster with the 350 bar. Toyota Mirai is still about 5 to 7 minutes, but if you're talking grams per second, it's slower, obviously. But really what you're trying to do there is prevent overheating of the tank itself.
Yep.
So
right, thank you.
You're
I'll be
welcome.
quiet. I could ask more questions, but I'll let others. Sorry. Fascinating
Well, hold on to
technology.
those.
Thank you for sharing.
Hold on to those questions, Jamie. We might have more time at the end. More questions for Jared. Oh, I see a question from Dave Roby. Dave, do you want to go ahead and ask your questions yourself, so I don't mess it up reading it? Dave, are you there? Okay, I'm going to ask Dave Roby's questions for him.
Okay.
Dave, I apologize if you're trying to talk and can't get through. He says, I have a couple of questions. First, how does the range of a hydrogen fueled bus compare to a diesel one? Go ahead.
Yeah, the hydrogen fuel cell buses are getting, I guess, and I'll quantify this, it's improved fuel efficiency, I guess, because they can take advantage of regenerative braking. So the fuel range that, we were just actually getting more data for this from Edmonton, but they are getting, I would just quantify it as better fuel mileage than the diesel buses because of the efficiency of the electric motors and the regenerative braking.
Okay. His next question is it viable for the facility to generate its own electricity from the hydrogen it produces instead of relying on an outside source of electricity, or would you consume more hydrogen than you generate?
Yeah, great question. So in case of a backup situation, we could generate our own electricity to do a fueling event. So that's kind of the nice thing about having methanol as a liquid carrier, is that we have feedstock available to us, so we can constantly regenerate. So in case of a power outage, or we could generate our own electricity, then it becomes, obviously we wouldn't want to do that all the time, but and we are looking to, we have some use cases now where we're doing hydrogen to the fuel cell to power generation for like fast EV charging and things like that. Yeah, just to be able to handle that energy and be able to utilize it. So the cost equivalency, it's, if you're talking, it gets a little bit more expensive when you're talking actually an OpEx, like you might be at 75 to $1 per kilowatt hour, but your CapEx and your ability to have power where you need it is less. So there's a bit of a trade-off there, I would say, I guess, if you're looking at that. So for remote power generation, we are looking at that, and it is looking like it's a really viable option for a zero emission power generation for remote sites where you could replace a diesel generator. Hopefully that answered that question.
Okay, thank you. Dave, you mentioned you couldn't find the unmute button. If you can find it, do you want to follow up on anything that was just said there?
I found it now.
Okay.
Great.
I'm used to Teams. No, that answered all my questions. Thank you very much.
Thank you.
Okay.
Dan Gaspar.
Hi, Jared. Very interesting. Love to see the application, and we think that transit is a really important application for hydrogen because of the range that you can generate, especially in rural areas. I didn't, maybe I missed it, but I may have missed hearing where you get your methanol.
Yeah, so great question. So today we have what we love about methanol is the availability of different feedstocks. So today we're using natural gas for some of our methanol, but some of our methanol, Enerclim had built a plant in Edmonton where they're doing municipal solid waste to methanol. So, you know, I tell people today we're making hydrogen from garbage. So we bought the last little bit of that and we're utilizing that. Then we are looking for other biomethanol sources. So either from renewable natural gas, biodigesters, and things like that. So we are looking for more and more biomethanol projects, and as those come on, like that's the nice part about methanol is it's the same molecule, CH3OH, whether it's in Alaska or it's in Washington, DC, it's the same molecule, so we get the same chemical. So that's nice for us from a scalability standpoint, is that we get that that consistency in liquid fuels.
And maybe a quick follow-up. Does the methanol reforming that you do, could it work with ethanol, which has much higher renewable availability?
Yeah, great question. So right now we're focused on methanol. Ethanol, you know, it's a different reaction and different catalytic reactor. So we had to choose one or the other, and we chose methanol. But you know, there's some viability for both and things like that. But there's some advantages to the methanol reaction temperatures and things like that. It reacts less at a lower temperature. So we see the advantages for methanol over ethanol right now. So yeah, we're continuing to develop that, and yeah, so we're impressed with the methanol reaction and the optimization we're getting out of it. So, and it's biodegradable. You know, I think somebody said that if the Exxon Valdez was methanol, it would have been cleared up in 7 days. So, you know, we like about that. Obviously, you can't drink it, but from a biodegradable and an environmental standpoint and ease of use of handling, you know, we always get to ask the question, why methanol over ethanol or ammonia? And it's for some of those other reasons that methanol availability throughout the country is widely available to us. So it's that reliable feedstock and the improvements in the different feedstock availability, like say from dairy manure to municipal solid waste. We hope to see more of those projects come on, and we are looking at for some of those other projects like landfill gas to methanol. So we are looking at some of those opportunities. So we have a pathway to a lower CI score, which I think will become, you know, a very cost-effective way to get low carbon hydrogen.
Forestry waste is another one that you can gasify and turn into methanol. But
Yep, exactly. So there's some of those projects, and actually some of that forestry waste in Alberta right now goes to California to make other products. So we are trying to advantage some of those, but yeah, that's what we like about it. There's promise, and you know, I think there's good economics coming to some of those projects, so we like it. And you know, we get such an advantage on the distribution and storage, that's where we see the cost effectiveness, being able to use an existing infrastructure to be able to move that hydrogen around. That's really what makes us be able to, you know, bring that cost down and the CapEx, so we can make these, you know, my frustration with hydrogen is that there's so many good things happening, but I want to do more faster, right? I want to do more. The vehicles, you know, I was talking to somebody in Korea, they have 50,000 hydrogen fuel cell vehicles going, and the data is, you know, showing that the vehicles are working so well. And so now I just want to be able to catch up to that. That's our goal.
Only 50,000.
It is a small number, but I guess it just proves like the data's out there that, you know, we don't need to do any more tests that test the vehicles. That's working. That's working. And it's zero emission, right? So if we can get, I try and tell people that if we can get to zero emission at the vehicle, let us work as oil and gas professionals. And it's maybe not a dig on anybody, but let us work on the rest of it. We'll get better every day. And that's what we're trying to do every day, and reduce emissions, obviously. But if we can get to zero emission at the vehicle, let's promote that adoption. Let's get that moving. And like I say, hopefully we can do more faster.
Thank you.
Thank you. Bob.
Thank you, Aaron. Jared, very impressive. Very nice job. Could you give us a little background on this project? Was this a joint project with the transit agency? You know, we all are kind of aware that, you know, you're in a very energy-rich environment. What is the cost comparison between, you know, what you're either getting, you know, diesel or natural gas versus what you're able to provide the hydrogen? So that background would be really interesting. And right now, how many buses are in use, and who manufactured them?
Yeah, so maybe start with that one first. So the buses are manufactured by New Flyer out of Winnipeg, Canada. They're the hydrogen fuel cell bus manufacturer. They use a Ballard fuel cell.
Okay.
And and then but there is a few others now getting into the bus market. That's one of the challenges with the buses, is that there's been a few that are come and again kind of halted some of their hydrogen fuel cell because they wanted to stick with diesels. But there's hopefully more coming to the market, and then the project itself here in Edmonton was a joint partnership with Emissions Reduction Alberta, the City of Edmonton, and ourselves. And the City of Edmonton is a great partner for us, in the fact that obviously you can see as the location we sit at the back of the fleet facility services. And so we had our own space where the buses, and this is behind the fence, so it makes it nice for them as well. But you know, they're a great partner, and I'll say this, in the transit world, you need a partner who's really gonna grab you by the shoulder if there's a challenge or a delay, and, you know, work through it, rather than, you know, sometimes, you know, we talk about contracts, and, you know, I've been involved oil and gas my whole life, and, you know, people like to, if we were selling to I won't name one of the majors, we denied working with them because they wanted to put us under a contract, and if we didn't supply by 4 o'clock, you know, we were going to be penalized. And so, you know, with a nascent technology like what we're dealing with, you don't need that kind of pressure on us. We needed a pressure that we could, you know, work together to understand schedules. Like, we were on a call this morning, scheduling, trying to figure out what works for the transit agency for fueling times, depending on their schedules and the routes they're taking, and when can we have, you know, what's the best for us too. So working through those logistics, so you can plan out a little bit of those fueling times, so that we can ensure that buses don't show up and it's efficient for them to roll through, so they're not lining up, you know, 4 deep and waiting for fuel. So, you know, that's that kind of integration and partnership you need. And, you know, we have been able to drive the cost down. And, you know, if you think of cost parity between diesel, there's lots of studies around there. It's anywhere from $7 to, I'll say, $9 per kilogram of hydrogen. You know, we're pretty close to that. I can't tell you the exact number, but we're almost to the single digits as well. So we're not too far off. And we hope to make that improvement. So, you know, we're only in month 2 of a 36-month project for them in this pilot trial. So we're making improvements. We've seen a 14% reduction in some of the energy usage from month 1 to 2, just by trying to smooth out some of those operational things. So yeah, we're definitely not in the, you know, high 20s or 30s that we're seeing. We're in the just over, you know, $10 or $10 to $12 is we think is a reasonable target, and that's what we're trying to get to.
No offense, but is that Canadian dollars?
Yeah, it is. So that's even cheaper for you. Like, that's only about $6 Canadian or US, I think.
Thanks.
Yeah, I think it's probably about
Thank
8 to
you.
9, 8 to 9, something
Yeah.
like that. But
Okay.
yeah.
Great. David Clark has his hand up. Go ahead, David.
Hi, Jared. It looks like a really nice compact plant. One thing, do you capture the CO2 and sequester it from the reforming process to reduce your carbon intensity, particularly if your methanol comes from natural gas?
Yeah, great question. So today we're not, but you know, we have plans to. The nice part about the entire plant that you see, it's somewhat modular in the fact that we can do both what I call bolt-ons. So CO2 capture is a bolt-on for us, and you know, the challenge with CO2 right now is, okay, it's great to capture it, but then what? And so we are looking at an efficient way to do that, and to you know, at the right cost, right? So we find this is a balance. This is what I talk about, the balance between deployable, scalable CI. What do you want to do today, and what's possible tomorrow? And looks like CO2 is one of those things that, you know, we'll continue to investigate and look for the right opportunities. But we see a little bit better opportunity to reduce the overall CI score by feedstock. Not to say we won't do that. And the CO2, because of our flue stream, and we do heat recovery system on the waste gas, so we do capture the heat out of that. We have an incinerator for the waste gas, so we do heat recovery, and that helps reduce the overall efficiency of the plant, or improves the efficiency. And so we are looking to capture that CO2 and do something with it. We just we kind of had to get operational first, and then it's in the plans.
Thanks, Jared.
Yep.
Thank you. Bob, do you have another question, or did you just leave your hand up?
Well, I did, and your other plant, I think you identified it as waste management. Now, is that waste management the company, or is that just your term for disposal services?
So it is at the landfill. They just it's the Edmonton Waste Management Facility. So it is at the Edmonton landfill. But it is
that the
city
waste
of Edmonton.
management Okay, so that's
No,
not
it's the
waste
city.
management. Okay.
Yeah.
Thanks.
Yeah. It's the city again. And so we're going to be doing, again, similar buses. We're doing some dual fuels. They have a refuse truck they're working on. So that will, and like I say, that's one of the sites we're looking at landfill gas to capture there and utilize at that site as well.
Okay. Great.
What's the lifetime or sort of duration of gas production projected from the waste management site?
Oh, great. Oh, great question. I don't know the exact answer for you. Yeah, if I told you, it'd just be a guess, but
okay.
I know that they did improve and they are capturing more of the gas than they originally thought. That was one of the challenges, was they had to upgrade the system to be able to capture more, because they had an abundance of gas available.
Mm-hmm.
And
so are your systems
commercially?
So are the systems commercially available, or are they all just in demonstration type stages?
Yeah, great question. So we are commercially available. We are like Winnipeg was an example of we did a partnership there with the city of Winnipeg. I shouldn't say a partnership. They bought the equipment and we're operating it for them. That was a unique one that again, just kind of the reason I kind of said flagship and it's a partnership because we are operating it for them and we'll continue to operate it for them. And we own all the IP out of it. They just bought some of the assets for the funding. So there was a balance there that helped them with their funding allocations and us with operationals and the running of the unit and an ability to, I guess, showcase the technology. And they are running 8 fuel cell buses and will be expanding to 16. And then above, I think their total plan is around 50 buses there.
Wow.
But as you can see with the location, sorry, go ahead.
No, go ahead.
As you can see with the location of Winnipeg, it's in the center kind of part of Canada. And, it kind of speaks again to the value proposition is that we were able to drop in there and make hydrogen in Winnipeg where, they couldn't get enough power to the grid. People were proposing hauling in liquid hydrogen. And when they did all the analysis, we just kept coming out on top of, over electrolysis and being able to get them hydrogen, in a shorter period of time at a price point that would meet their actual budgets. So the nice part about that project was that, it was looking to be canceled until they came up with, a production method that would meet the budget and allow for them to go forward. So, I think it's a really, I'm so proud of our team to be able to work to be able to do that and to facilitate and enable, 8 fuel cell buses that otherwise wouldn't have hit the road in Winnipeg, right? The project probably would have been canceled or, they would have had other challenges. So.
Okay. And I'll ask one question and then hand it over to Dave Roby. What are the plans for scaling this operation?
Yeah, everywhere you see one of those yellow dots on this map, and including we included the red dot up in Alaska. We'd love to be able to scale across the country. To go across kind of North America, like from one coast, from California all the way to, New Jersey or you need about 20 stations. So, every 500 kilometers or 300 miles, we would love to be able to put a station, then you could drive a hydrogen vehicle across the country. So, those are the kinds of things that we're looking to do. And, now we're just trying to, I guess, right size ourselves and be able to continue executing on the projects. I told you this project experience is one of my favorite slides because it illustrates our ability to execute. I mentioned there's a lot of hype in hydrogen, and we're actually doing it and building hydrogen and making hydrogen today, and we're profitable. So, with all these bad news stories about hydrogen, we're proud to be one of the good news stories and, making hydrogen happen. And that's our goal. And from the onset was to make hydrogen happen. And, we saw some of the challenges that the industry was faced with. And, unfortunately, we took a lot of headwinds and we're still doing it. But I think, I told our group this morning that if we can make hydrogen today and we can make it through the tough times, when things come back and things settle out, then we'll be in a better position to be able to do more. So that's really what we're trying to do up and allow a lot of municipalities that have already committed to hydrogen. We're trying to help fix some of those problems and bring hydrogen to them.
Thank you. Dave Roby.
What's the life expectancy of one of these units, and how frequently, if at all, will you have to shut down for an extended period of time to do maintenance?
Yeah, 20 years is the lifetime of the equipment. And so we're trying to, obviously we have maintenance, we have maintenance scheduled, and we're trying to do that on the weekends or at specific times and in smaller chunks as well, so that obviously at certain times we'll change out either catalysts or emulsives, things like that. That might take a day or two, but that's the nice part about being a smaller facility, is that we have like smaller motors and smaller equipment, and we're actually doing a lot of work right now on replacement parts to have, so we can swap out motors, things like that, in a shorter period of time. So again, the goal was always to have 100% fuel availability at the storage tank and the dispenser. Not that the production will run 24/7, but and we've been able to manage that so far. So, you know, that's kind of the plan. So we'll do some scheduled maintenance, but with hopefully very limited impact on the fuel availability.
Thank you.
And Bob.
Jared, I think you heard at the beginning of the call that last week the federal government basically took away about $8 billion from hydrogen development. Does Canada still provide some incentives and subsidies? Because, you know, that's like you said, you need to get the ball rolling and deliver, and it helps to have some assistance, you know, from local government, but also from the federal government. So what is the situation? Obviously, Alberta is, you know, very pro, but what about Canada as a whole?
Yeah, so great question. You know, Canada does have a clean fuels regulation, so there is some incentives to have low carbon fuels. There is some incentives and some programs for the municipalities to push some of the fleets to zero emission, and there is some funding there that's continuing on. You know, like everybody else, Canada is looking at, you know, how they're spending some of those dollars, and those are getting reviewed, and I'd say it's pulling back a little bit, but I think for the most part, yeah, obviously we have some great support in Alberta for hydrogen, and hopefully across the country now as well, and we can do that. And we're still hopeful, you know, like in California, and we are working with the major OEMs trying to see if we can work together to solve some of the infrastructure problems. And we hope, like right now, we're one of the few, I guess, technologies that aren't reliant on subsidies to make a project profitable.
Good.
So yeah, I think, you know, that was another one of our, I guess, my oil and gas experience paid off there in the fact that we knew we had to be profitable regardless of subsidy. So we're not reliant on, you know, if we got this credit or not. I think that was one of the learnings we saw in California, was that a lot of these projects were heavily weighted, and you know, we took a little bit more balanced approach to that, and just wanted to get started. You know, I thought that was a key driver for us, is be able to get the deployments happening and not wait for mega projects. And we wanted to de-risk the deployment and the availability for hydrogen. You know, if you're talking $1 billion project, that's a lot of those are hard to get across the FID. And so we saw that as a major challenge. So we thought we're, I guess, pretty contrarian in the belief that, you know, one of the ways to get hydrogen cost down was, you know, everybody looked at big centralized production, and we looked at smaller, more decentralized and, you know, widely distributed production. And again, we looked at, can we take advantage of existing infrastructures and be able to keep that cost and CapEx down? So that was one of the main drivers around it, and I guess it's worked out for us, and we'll continue to try and drive that forward.
Thank you.
Thank you. Any further questions for Jared?
Yeah, this is Robert. I couldn't find my my hand button. So, Jared, great presentation. Love the fact that you weren't waiting for the large projects. You were just getting things going smaller. I think that's the way to introduce new technologies like this, and you learn and you grow from there. Super. One of the things I've questions I got for you on your map, you've got some methanol import terminals. I was just wondering where you're anticipating bringing in the methanol from. Is that a future kind of idea, dream kind of thing, or what's that about?
Yeah, no, this is an existing map of import terminals now. So the nice thing about methanol, again, from a supply standpoint, a lot of marine and the shipping guys are looking to methanol, like Maersk is converting some of their big ships to methanol. So I guess we were trying to tag on to that as well and follow them, because if they're bunkering, they use so much methanol. We are banking on the fact that they will keep the cost of methanol low enough to be able to allow it to be used as a fuel for their ships, and then they'll have to have it at major shipping facilities. So these ports, like in Texas, and actually it's probably not inaccurate, but because there's one down in California, you know, these are accurate, and the methanol availability is all throughout North America. So we just kind of picked this one, but we can show you where it's being railed. And the nice part about methanol, yeah, as a liquid, you know, we can put it on a rail car and ship it across North America. So we are working with the major methanol producers like Methanex and Proman and a few others to try and solidify some of those and how we can bring it in and distribute it a little bit easier for us. So we're working on that logistics side as well. We handle all of that in the background. So really our clients just really have to show us and tell us how much hydrogen they want, and we make that happen. We've handled all the logistics of the methanol supply and distribution of it. And we've worked with one of the major distributors as well. So like in Carson, California, just outside of Los Angeles, there's like 300,000 gallons available to us at any given time. So there's large quantities.
Good, thanks. That's a great, that's a good way to go as well. So following on Maersk is usually a good company to follow up with as well. So that's good. So again, you're taking the methanol route for the practicality of the availability of your source energy kind of thing. And I guess you've got the modularity to be able to take pure hydrogen when you get to that point, right?
Yep, exactly. So we're making the hydrogen kind of as close to proximity where you need it, or if you need it, we're trying to keep that in a close area. Like, you know, we are trying to look at potentially we'll start to build some higher production hubs that will do a little bit of a hub and spoke model, where we'll start to deliver maybe, you know, 20, 25 miles away, so we can expand from the site itself. So we have some plans to do that, but for the most part, we are looking to produce where they need it, and that's the most efficient way. But we are also cognitive that, you know, as we start to build up a little bit more, we can supply and deliver hydrogen in that smaller radius. We think that 25-mile range is about right. You start trucking it too much further than that, it becomes a challenge with cascading and deliveries and logistics, things like that. So
yeah, okay, yeah. And so I guess I was also meaning something about producing hydrogen other than methanol. So once you've got the capability to do that, you'll be able to you know, feed that into your system. Or now you've got different sources of hydrogen. Will the different ways of producing it give you different contaminants is the wrong word, but you know what I mean?
yeah, so, you know, right now, like I say, we're happy with methanol because it's that same molecule as I mentioned. There is some, like, we looked at natural gas small SMRs, but the challenge with natural gas SMRs is that in, you know, California versus Illinois, there's different the contaminants in the gas. Like, natural gas isn't natural gas across the board, whereas the molecule of methanol is the exact same. So And, you know, I should point out too that, you know, we have a methanol reformer today. We are looking at dual modal. So you could combine a methanol reformer with an electrolyzer. To be honest with you, I'm just waiting for the electrolyzer technology to improve a little bit better. But we're not opposed to using like dual modal systems, or if somebody comes along and with a, you know, a better mousetrap that shoots around the corner, you know, we're going to look at that, because he's still going to need compression, storage, and dispensing, and we're going to have a network of fueling sites, so you'll be able to take advantage of some of the infrastructure we're putting in place, no matter how you make it. Or
yeah,
that's
where I was aiming at, because obviously we want to reduce the carbon cycle where we can, and while you reduce it from the vehicle emissions, you've still got to do something with it at your production site there. So that's good. Yeah, one of the issues with carbon capture and storage, or carbon capture hubs, is the fact that you're bringing it from different places, and you can you'll have different contaminants, which mean you've got different issues with your materials for downhole storage, for example. So yeah, thanks very much.
Yeah, you're very welcome. So yeah, we hope to see, like say, we're trying to work with others. You know, the challenge with every different area is that, you know, some have you know, cheaper power available. Some don't. The grids are a challenge. You know, today in Halifax on the east coast of Canada, you know, 40% of our electricity comes from coal. So, you know, that's not a great use case there for electrolyzers or something else. But so, you know, I think we're trying to look at these different areas, but I think you know, this allows us to get hydrogen going today faster than we've seen some of the other technologies. But like say, we're working with others to try and watch that and see what happens. But for today, and I, you know, I think the 3 to 5 year outlook, we're very happy with the performance we're seeing, and the pathway we see for a low carbon hydrogen at the end of the day. Because at the end of the day, don't get me wrong, the whole point of our project is to reduce emissions, overall emissions, right? And I think there's a lot of work when you say that to, you know, overall, and what's being compared fairly to. I always try and justify this to people that you need to compare apples to apples, like yeah, because I think there's a lot of fudging going on there.
Again, your progression from the small projects, you get one step, you can transition into you know, better environmental cases down the road as that is available. And Aaron's group up there, Arctic Energy Office, is a great place to figure out where you've got excess electrical energy to be able to produce it. So that's why I ended up with this group.
Terrific. And there was one question in the chat. Did you say that you were currently working towards a project here in Alaska? I think the answer there is no, but you pointed out, you know, opportunities in Alaska regarding, you know, methanol production with Alias Chem on the North Slope. Is that correct, Jared?
Yeah, we'd be very much open to that. Obviously, if you're making your own methanol up there, we'd be open to that. And one of the things we like, and the reason we got chosen for Winnipeg too, is, you know, we were able to show that we had filled the, in Innisfail, Alberta, CPKC, one of our major railway guys, have hydrogen trains. And we were the first one to compress and fill that train at 350 bar. And we did it at minus 45 degrees C. So we've had some cold weather operation, and the unit performs well. And so yeah, you know, we might have to do a little bit more to get to the Alaska temperatures, but we're pretty close there. For minus 45 is still pretty cold, and we're impressed with how the units.
Yeah.
T-shirt weather in Alaska.
Yeah.
That's right. That's right. Thank you. Any final questions for Mr. Sayers? All right. Well, thank you again, Jared, for the presentation. Very interesting, and you certainly sparked a lively round of questions and discussion. I'll ask you, Jared, to put your contact info in the chat for folks to follow up with you if you don't mind. yeah, thank you again. Really, that was terrific. And as you said, it's a bright spot. So it's good to hear.
Thank you.
Before we close out, I'll just remind folks that our next meeting will be on Tuesday, November 4th. Patty, if that's not right, please jump in and say something, but that's what my calendar says. And are there any further announcements or anything for the good of the group before we log off here? All right. Well, thanks again, everyone. We'll see you in a month. Until then, be well. Take care. Bye-bye.
Have a good day, everyone.